Now, let's say we pull up our solve the equation here. Oh, let me just make it shorter. So, pulling out your solve equation that you memorized, you need to know which equation you need to use now. So, it's v equals to u plus at, v squared equals to u squared plus 2as, s equals to ut plus 1 over 2 squared, and others. So, which one do we use? Actually, since if you noticed, we can use actually this equation. Let me pull it up. S equals to vt minus 1 over 2 at squared. So S is the question mark. That's what we need to find. V times t. So V is going to be 0. T is going to be 2 seconds, but anything multiplied by 0 is going to be 0. Minus 1 over 2 times the negative of 9.81 and 2 squared. Put this in your calculator, you should get approximately 19.61 meters. And you should round up to 2 significant figures, but even though this is 1, it's still rounding it up. In physics, you always have to round it up. Physics AS level, you have to round up to 2 significant figures. While in other subjects like math and mechanics, you have to round up to 3 or 4, depending on the paper. You have to read the syllabus. But in physics, there's 2 significant figures. Now you don't have to write the 2 significant, two significant figures. You don't have to write that, but if you can, that'll be really good. So now you know how to do this. But so in this, after that calculation, we can conclude that the height of any object is going to be 1 over 2 times acceleration times time square. So, but this rule can only be used if it's used for falling bodies. Falling bodies is what do you call it? An event only related to the vertical component. Okay, not horizontal component. If it's horizontal like this, oh sorry, that's a bad circle. Whatever. If it's like this, then it's not going to be good. Sorry, it's not going to be working. However, if you do it like this, it can work. Okay, and if it's like this, it can make it work. Diagonal, you have to convert it, but that's going to be for another chapter. So that's going to be taught later. Now there should be there's 3 types of falling body graphs that you should be familiar with. One is the velocity time graph, and the gradient is going to represent the acceleration. So the velocity time graphs without the air resistance is going to accelerate continue to accelerate constantly. So it's going to go straight line going up. While with resistance, which is the green one here, is the graph curves at its as it decelerates and levels off to a terminal velocity. Terminal velocity is when you have a constant speed. Okay, so you just need to memorize the idea of it. You can memorize easily because the imagination is logical. So the grade acceleration should be look like this with air resistance because of the wind. Okay, while in space it's going to go straight all the time. And a distant time graph, it's going to be different because accelerating or without air resistance, it's going to it's going to continue to curve as it accelerate. Yeah, it's going to curve. That's what you should know. I know I drew a straight line, but normally, because of my terrible drawing skills, it's going to go curving. But with air resistance, it's going to level off. Yeah, it's going to level off as into a terminal velocity, until this really ends. So the gradient represents velocity. Oh, what is this? Velocity. Oh, let me rewrote that. Anyway, you get what I mean. The gradient is the slope that represents this line. It's going to represent the velocity. So the last type of body graphs can look like this: acceleration time graphs. So get this drawing. So you don't need to know about the gradient of the you don't need to know about the gradient of the acceleration time graphs, because it's not in the syllabus and it's not taught in the book. But you should know that with air resistance, okay, let's say a car or a box is moving and there's a force applied here and it's moving forward, and then when it stops, it means that the force that is applied here is being resulted by another force opposite direction, making the resultant force 0. But if it's in space, there's going to be no air resistance, so it's going to be going straight all the time. So these lines will represent the change of velocity, because acceleration means velocity, rate of velocity, rate of change of velocity. So it's not going to change. It's going to keep accelerating, constant speed. So okay, that's all. That's the 3 type of falling body graph that you should know. Now finally, we're going to talk about the last topic in this chapter, which is projectile motion. So projectile motion is the idea of horizontal and vertical motion. Okay, an example is in the exam, I got this from the exam paper. In a real situation, a ball is going to be kicked in a specific angle, and it's going to be moving at a speed of 10 meters velocity of 10 meters per second, and it's going to hit on a wall. Okay, but this diagram doesn't look too simplified, because when you simplify it, you'll get a triangle that looks like this. Alright, projectile motion is curve. Okay, the definition I'm reading in my notes here says a uniform velocity in one direction and a constant acceleration in a perpendicular direction. Okay, so what does that mean? Is that I don't know if you can see it very well because of my window screen, but I'll move down. Okay, so what that means is that when you have a horizontal component, it's going to have a constant velocity, and the vertical component is going to have a constant acceleration, which is 9.81, which is pulling it downwards. But you use basic trigonometry to solve this. So kotoa. No, because physics is going to be um, using math to explain things a lot. So that's it for this video, and that's the final topic that you should know, and I'll see you next time.